Welcome. In this video, we're going to be working the rational root theorem quiz for Algebra 2. Okay, so I think I'm just going to, rather than just give you the rational root theorem, I'm just going to work number one to remind you how it goes. So we're going to use the rational root theorem to give all the possible rational roots of the polynomial. So the way this works is a rational root can be expressed as the ratio of two integers. And the integer on the top is going to be a factor of the constant term. By constant term, I mean this negative 9, the number that doesn't have an x attached to it. So I've got plus or minus 9, 3 is a factor of 9, and so is 1. Okay. Numbers that if I divided 9 by them, I would get an integer back. Okay, q is going to be a factor of the leading coefficient, which in this case is 2. So I've only got two factors of 2, I've got 2 and 1. Okay, so what I do is I combine all of these in all of the ways that I could, combine them to get different numbers when I divided 9, 3, 1, and their negatives by 2 and 1. Okay, so I'm going to say, okay, I could divide 9 by 2, or I could divide 9 by 1. I could divide 3 by 2, or I could divide 3 by 1. And I could divide 1 by 2, or I could divide by 1 by 1. Divide 1 by 1. Okay, and that's going to be my list of all possible rational roots using the theorem. Okay, number 2, more of the same, but number 3 is just take the same polynomial and find the actual roots and give the multiplicities. Okay, we'll be able to do that. Okay, so the possible rational roots will be, the form p over q, where p is any factor of 8, so I've got 8, 4, 2, and 1, and q is a factor of the leading coefficient. Okay, the leading coefficient, if I only have x to the fourth, that's 1x to the fourth, so I've just got 1. Okay. Meaning that my set of all possible rational roots is 8 divided by 1, 4 divided by 1, 2 divided by 1, 1 divided by 1, and the negatives of those. So okay, now when it comes time to finding the actual roots, which we're going to put down there, I'm going to just kind of take your pick from these. I think the wise algebra student in my class is always going to start with positive 1, right? Try 1 first. If that doesn't work, try negative 1, because I've made one of those, made sure one of those is a root, because I'm not trying to make you go on any sort of like crazy hunting expedition. So what we're going to do is we're going to try x equals 1. And we're going to do some synthetic division. I don't usually put the plus in, but it's not hurting anybody, so I'll just leave it there. Okay, now I put in x equals 1, I've got 1, 1, negative 2, negative 2, negative 4, negative 4, negative 8. Whoa. Nope. 12 minus 4 is not negative 8. That's going to be positive 8, and then multiply that over here, and I get 0. Okay, that's good news. So x equals 1 is a root. Okay, it's also a factor of p. So I think I'm going to rewrite p right here. P of x is equal to, okay, I just factored out that x minus 1 with that division I did. And what I'm left with is 1x to the third, negative 2x to the 2, negative 4x, and positive 8. What else? I feel like I had something to say about this, but okay, I can't remember it. The second thing in parentheses, the thing with 4 terms, that's going to be something I can group and factor. So I'm going to say from the first 2 terms, what am I getting? X squared. I'm left with an x minus 2. And then negative 4 times x minus 2 again. That's a good sign. And we're going to need to make this a little smaller. I'm starting to run out of room here. Okay, so we'll keep going. Factor out the x minus 2. And get x squared minus 4. I can factor x squared minus 4. That's a difference of 2 squares. Okay, and that's as far as I can go. Okay, so I'm saying the roots with their multiplicities. Okay, this one will give me x equals 1. Okay, that's going to have multiplicity 1, but I'm just going to call that a single root, and I'll write all those in at the end. X equals 2. I see that twice, so that'll be a double root. It'll have multiplicity 2. Then x equals negative 2. And so, yeah, we're going to report all the multiplicities. You can say multiplicity 1 for single root or multiplicity 2 for double root. I've just been mainly using single and double root as the terminology in my class, so I'm just going to stick with it. Number 4 says, okay, f's a polynomial function with rational coefficients. So the rational root, so that theorem about irrational roots will apply. F of negative 2 plus the square root of 11 is 0. Okay, so just to unpackage that statement, okay, that means that x equals negative 2 plus the square root of 11 is a root of f. Yeah, I know it says it implies it later, but I just want to be really explicit about that. Okay, so if we know that a plus the square root of b is a root of a polynomial with rational coefficients, then x equals a minus the square root of b is also a root. Okay, so that would be my answer. That what number besides x equals negative 2 plus the square root of 11 is a root. Okay, negative 2 minus the square root of 11. We don't need to know anything else about the polynomial besides that it's a polynomial and that it has rational coefficients. Second, number 4, it looks like, write a polynomial of minimal degree with zeros here and there and a leading coefficient of 2. All right, so if x equals 1 is going to be a 0, then x plus 1 will be a factor. X equals square root of 7, so x minus square root of 7 will be a factor. Now it doesn't say, but I remember in my class, like actually in class, I just said out loud, okay, number 4 and 5 on the back, I say a polynomial of minimal degree, but I mean a polynomial of minimal degree in standard form with rational coefficients. So they had to say, okay, well, if x minus root 7 is a factor, then x plus root 7 has to also be a factor. And there could be some leading coefficient a there. Now, when they say that the leading coefficient needs to be 2, I know I'm going to go in and I'm just going to replace a with 2 at the next step. And I'll show you that at the end, when I put it out in standard form, that this will get us, make sure that the leading coefficient's 2. So y is going to equal 2 times x plus 1, and then I might, multiply these two things together. So I'd have x squared, and hopefully you've done a few of these by now because I'm not going to write down the middle terms because they're going to add 0. Plus root 7x minus root 7x, that goes to 0, minus root 7 times root 7 is minus 7. Okay, and then now I'm going to do a little bit more distribution. I'll deal with the 2 last. Okay, so x times x squared is x to the 3rd, plus 1 times x squared, minus 7 times x, and plus 1 times negative 7. Okay, and then to get it in standard form, we're going to distribute the 2. And we know that it's got those roots because we made sure with factors, and it's got that leading coefficient of 2 like was requested, so I'm happy. Okay, the next one's a very similar problem. They're going to give us a double root at x equals 0. So y is going to be some number times x minus 0 squared times x minus 1 minus square root of 6. If 1 minus square root of 6 is a root of this polynomial that's going to have minimal degree and rational coefficients and be written in standard form, then x minus 1 plus square root of 6 also is going to need to be a factor. Okay, so I'm going to distribute the negatives, and I'm just going to let a be 1 because nobody said anything about what the leading coefficient had to be. So we can just make it 1 because that'll make our lives easiest. And x minus 1 minus the square root of 6. Okay. Now, hold on. Forgot what I was thinking here. Okay, I think I'm just going to multiply these two things out. I'm going to use a box for it, and I'm probably not going to have room to keep it after I'm done, but x minus 1 plus the square root of 6. I'm going to fill that out real quick. I don't think you need to watch me do that. And now that I've got the box filled out, I'm going to combine the like terms and report that. So that's x squared minus 2x plus 1 minus 6. And all of the stuff with a square root of 6 in it, it had a friend to cancel off with, right? So, okay, our job here is done. And over here, I've still got y equaling, we're going to let a equal 1, because, again, no specification on the leading coefficient of this polynomial. Then when I distribute the x squared, I'll get x to the 4 minus 2x to the third minus 5x squared. And that's going to have the requested properties. All right. Now we're going to let p be the polynomial x to the 3 plus 2x to the 2 minus 5x minus 10. X equals root 5 is a root of p. Find the other two roots. Okay, that means x equals negative root 5 is also a root of p. I'm also realizing that this polynomial is factorable. So that's also a way you could have gone. I haven't graded these quizzes yet. But when I do, I'll be interested to see if anybody used that technique on this one. Okay, well, let's keep moving. So I'm going to work this one the way I showed people how to work it this morning before the quiz. Did not even. I must have. I think I was working with a 4th degree polynomial in the practice problem. Anyway, I'm going to just drop this down. I'm going to run square root of 5 through synthetic division, because why not, right? I had not really considered this before, but you know, there's nothing wrong with a radical number. You can run it through synthetic division. You can do whatever you want. So we're going to multiply root 5 times 2 plus root 5, and I'll get root 5 times root 5 is 5 plus 2 times the square root of 5. And then this is really nice. When I add these two things together, the negative 5 plus 5, that's 0, so I just have 2 square root of 5. And then when I multiply 2 root 5 by root 5, I'll have 2 times regular 5, which is going to be 10. And then I get 0. Okay, so that's what I would expect. They told me that root 5 was a root. So, okay. Now, the theorem about irrational roots told us if we've got a polynomial with rational coefficients, and you know we've got square root of 5 as a 0 of the polynomial, the negative square root of 5 is also going to be the 0 of the polynomial. And the nice thing is when you do the second layer, all the square root of 5s cancel out, because this is making sure that we have rational coefficients. This is kind of how it's working. And I keep this going and I get 0. Okay, so the factors of p are going to be x minus square root of 5, x minus negative square root of 5, and whatever I'm left with here, that's going to be 1x plus 2. Okay, so the original root was x equals square root of 5. The other two roots are x equals negative square root of 5 and x equals negative 2. Okay, so these are the other two roots. All right, now let's work form B. I'm going to go a little faster through this one, and if you need more explanation on a given problem, just go flip back to form A, because the problems are exactly the same with different numbers. So P is going to be a factor of negative 4, so that's plus or minus 4, 2, or 1. And Q is going to be a factor of 3, which is just 3 and 1. So my set of all possible rational roots would be plus or minus 4 thirds, plus or minus 4 over 1. Do the same thing with 2 and then 1. Wait. I forgot one of them. Okay, I didn't put 1 divided by 2. Yeah, I put both with 2. Yeah, it's 2 of each. All right, there we go. Okay, we're going to do the same thing for number 2, but then on this one, we're going to actually find the roots. So the possibilities are going to be, okay, factors of 27 divided by factors of 1. So it's just all the factors of 27. Okay, 9 is a factor of 27, so is 3. I can't think of any others. I hope there's not any that I'm not thinking of. I think that's it. Okay, so these are my possibilities. Okay, now I'm going to try some of these until I find one that works. I think I'm going to start with x equals 1. And you know me, I tend to guess right a lot. I'm a pretty lucky guesser, I suppose. And so 1x to the 4, 2x to the 3, negative 12x to the 2, negative 18x, and positive 27. All right, we're going to try x equals 1. Wasn't looking good for a while. It's kind of the numbers were getting bigger. I felt like it wasn't going to happen, but it just worked out right at the end. Sometimes you just got to have faith, okay? And x equals 1 in my class is very frequently a root. okay, when you have to do this. So just keep that in mind. All right, so now that I've got x minus 1 factored out, I'm left with x to the 3 plus 3x to the 2 minus 9x minus 27. Okay, that's something I can do group and factor on. Right. Not much room. X minus 1, I'm going to factor out x squared and be left with x plus 3 out of the first two terms. And then out of the second two terms, I'm going to factor out a negative 9, and I'll be left with an x and a plus 3. I've got x minus 1 times x plus 3 multiplied by x squared minus 9. Okay, x squared minus 9 is the type of thing I can take a little farther because it's a difference of two squares. I'm going to call that x plus 3 times x minus 3. Okay, and from there, I'm going to report the roots with their multiplicities. X minus 1 tells me x equals 1 is a root. That's going to be a single root because I only see that factor once. X equals negative 3. That's going to be a double root because I see that factor twice, right? It's going to have multiplicity 2. And x minus 3, that tells me that x equals 3 is a root, and that's going to be a single root. F's a polynomial function with rational coefficients, and f of negative 4 minus root 10 is 0. What x value besides negative 4 minus root 10 must also be a root of f? X equals negative 4 plus the square root of 10. Okay, because of the rational coefficients and that fact there. Those two things together tell me that there must be another one, and it has to be negative 4 plus the square root of 10. Right, on this one, we're going to write a polynomial of minimal degree with zeros at negative 2 and root 5 and a leading coefficient of 3. Okay. Well, if x equals negative 2 is a 0 of the polynomial, x minus negative 2 will be a factor of the polynomial. If x equals root 5 is a factor, a 0, then x minus root 5 is going to be a factor. And, okay, and I said it when I was working Form A. In my class, I mentioned out loud that on these problems, this one and the next one, I didn't write it, I meant to. But I meant a polynomial of minimal degree in standard form with rational coefficients. So if it's going to have rational coefficients, I need x equals negative square root of 5 to be a 0 as well. So x minus the negative square root of 5. And, polynomial is usually an equation in our class. And there could be some leading coefficient, as we're seeing. It says that the leading coefficient needs to equal 3. Well, that's what I'm using that a for. So I'm going to use a equals 3, and I'll show you how that's going to cause us to have a leading coefficient of 3. But I think since I'm writing a new line, I might as well multiply these two things together. These two things will combine to make x squared minus 5. Okay. You can do FOIL, you can do the box method, however it takes. I just need you to distribute all those terms over each other, see the two that are canceling out, and see that you're left with x squared minus 5. Okay, I'm going to do a little bit more distribution. I'll get x to the 3, 2x squared, negative 5x, and negative 10. I'll distribute the 3 over all that. And I'll have a standard form polynomial with rational coefficients with given zeros and a leading coefficient of 3. So notice how that worked. All right. Now we're going to write a polynomial of minimal degree with a triple root at x equals 0 and a single root at x equals 2 plus square root of 7. Again, polynomial standard form rational coefficients. So triple root at x equals 0. That means x cubed is going to be a factor. Single root at 2 plus square root of 7. Okay, that means that 2 minus the square root of 7 is going to also be a root. If 2 plus the square root of 7 is, and I'm going for something with rational coefficients. Okay, it could have some leading coefficient, but nobody said anything about what it had to be, so I'm just going to let it be 1. Nothing wrong with that. And now I'm going to get to distributing. I think first I'm going to do these two together. I usually do the box method on these, but I recently learned a new technique from a different Algebra 2 teacher, and I really thought it was kind of slick. So I'm just going to show it to you. If you want to just use the box and multiply out, hold on, I'll show you what I'm doing here. Minus 2 minus square root 7. If you want to multiply these two trinomials by each other, the way that we're familiar with, the way I showed you how, you should definitely do that. But if you're interested in a different way, have a look at this. Okay, so we know that x equals 2 plus or minus square root 7, right? So we could say x minus 2 is plus or minus square root 7. And I might square both sides of this equation to get rid of the radical. Now notice that regardless of if you square positive root 7 or negative root 7, you're going to get 7 when you square it. And then x minus 2 squared, so okay, I'm going to need to distribute that. That'll be x squared minus 4x plus 4 equals 7. Oh yeah, and if we want the factor that we're to multiply in there, we would just say it's equal to 0, right? Yeah. Yeah, because x minus 2 plus or minus root 7, that's equal to 0. Yeah, that's why this is able to be set to 0. I think about that when I saw this technique. X squared minus 4x minus 3. Okay, so we're going to take that, and that's going to be the product of these two things. Which is itself factorable. No, it's not. Okay, this is one of those ones that looks like it's factorable, but it isn't. That one looks really factorable to me. But, you know, negative 3 and positive 1, that's going to add to negative 2, not negative 4. So that's why that one's not factorable. That one's very tricky. All right, so now I'm going to distribute that x to the 3 across this trinomial, and I'll get x to the 5 minus 4x to the 4 minus 3x to the 3rd. And that'll be in standard form, rational coefficients given zeros. Right, now the last one is going to be x equals square root of 6 as a root of p. Find the other two roots. Okay, I'll do that. So I'm going to set up for synthetic division. I will comment that this is factorable, and I'm going to work that off to the side after I do this. Okay. Whoa. I've done something horribly wrong. All right, 3 square root 6 plus 6. That's going to make 3 square root of 6. That'll be positive 18, and that'll be 0. Okay, square root of 3 just didn't really have any business in this problem, so that should have been a bad sign. Okay, if I know that x equals square root of 6 is a 0 and p has rational coefficients, then I know that x equals negative square root of 6 is also a 0, So I've got factored up, this would look like x minus square root 6, x minus negative square root of 6, and 1x plus 3. Right, and so my roots are x equals square root of 6. They already told me about that one. X equals negative square root of 6, that's a new one. And x equals negative 3, that's the other one that I didn't know. Okay, so those are the other two roots. Okay, now if you wanted to see how this was factorable, I'll just show you real quick. Right, so we could do group and factor on this. In fact, I feel like we've done group and factor on an equation very similar to this already in this course, but that's just another way that you could arrive at that same solution. All right, that's it for this video. Thanks for watching.